These are the steps for solving equations. Number 1 is you need to simplify, which means to combine your like terms and to clear any parentheses that you may have, whether that be distribution or combining like terms. Number 2 is to number what is happening to the variable first, second, etc. 3 is to undo the last step. So if you've got a third step, that's where you're going to start, and you're going to use opposite operations to undo that step. Number 4 is to go to the next to the last step. So if you've got a third step, you're going to go to the second step next, and you're going to do again the opposite operation that is performed there until you've got x isolated, meaning that you've got x by itself. And number 5 is to check your work. Always check your work by substituting that value back into your equation and making sure that is a solution for that equation. Okay, we're going to complete this example right here. We have 3x minus 2 times the quantity 2x minus 5 equals 2 times the quantity x plus 3 minus 8. So we notice here on our left hand side we have a lot of stuff going on here. On the right hand side we have a lot of stuff going on here. So we need to simplify this because again we've got parentheses here and parentheses here. This right here is a negative 2, so we actually need to take that 2, that negative 2, because remember that sign goes with that number. So we're going to take this negative 2 and we need to distribute to all the items inside the parentheses. So we get 3x minus 4x plus 10. If I look on our right hand side, this 2 needs to be distributed. So we have 2x plus 6 minus 8. So we've cleared the parentheses, but this is not completely simplified because again we have like terms here and we have like terms here. So we need to simplify this by combining our like terms. We have 3x minus 4x, which is a negative x or a negative 1x. We really don't need that 1 up front, but if you need to put that there, you can. Plus 10 equals 2x. And we have 6 minus 8, which is a negative 2. Okay? So this is completely simplified. This is step number 1. And so we're going to move on. Now, one step that was not given in there is a step that we need to put in before we start counting what happened to x first. Because as you notice, there's an x on the left-hand side and there's an x on the right-hand side. You need to move the x's so that they are all on one side of the equation. Now you have two choices. You can either move this negative x over to the right-hand side, or you can move this positive 2x over to the left-hand side. For a word of caution, I suggest that you move the smaller of the two, always, because you want to try to keep your x's positive, and if I move this over to the other side, I'm going to do the opposite of what's going on here, so I'm going to add it, which makes this a positive, so we're good. But if I take this 2x to the left-hand side, I have to subtract it, which then will make my x or my variable negative, and I don't want negative. This is going to help save you some steps in some of the sections to come. So we're going to add x to both sides. That's going to cancel. So I get 10 equals 3x minus 2. Now I go through the process of asking myself what is happening to the variable. The variable is being multiplied here and subtracted here. Okay, so again I go backwards. I start with my second step and I undo this. So it's subtraction. I undo it by adding. Sorry, thinking ahead. So I get 12 equals 3x. I have to undo what's going on here. This is multiplication. The opposite is division. So I get x equals 4. And then you would go through, stick this back into your original equation, and then check your work. This is our next example. Sometimes you may come across equations that have fractions in them. I know that how you guys don't like fractions. I don't like fractions. There is a way of getting rid of the fractions in this case. You can work these out with the fractions as written. You could find an LCD, change all of them to a common denominator of 12. But that's really a pain in the butt. There is a shortcut, but I have to warn you. only use this shortcut on equations. Again, equations meaning that there is an equal sign. I don't want to see this shortcut being used on like 1/3 plus 1/4. That is not an equation. That is an actual addition process that needs to be done. You're not solving for anything. You're just working the problem out. Here we have to solve for the variable, which is x in this case. Okay? So in order to work this out, we have to find the LCD first. So we do have to find the LCD even though we're not changing these to fractions. Okay? LCD is 12. Do not tell me 24. Okay? The thing that we're going to do now is we're going to change this. The reason why we find the LCD is because this is going to allow us to get rid of the fractions. You're going to multiply everything by 12 over 1. And I do mean everything. Because again, what you do to one, you have to do to all. Okay, so again, everything is being multiplied by 12. Now you're going to go through and cross cancel. For those who don't like to cross cancel, this is kind of needed right here. So 3 goes in a 12 4 times. So I'm left with 4 times the quantity, x plus 1, minus 4 will go into 12 3 times. These have to multiply, so I get a negative 3x. And then 2 will go into 12 6 times, so I get 6. Okay, so this is what I have right now. Again, notice it went from that down to this. No fractions. Pretty sweet, huh? Okay, I need to combine or simplify my left-hand side, so I need to distribute. So this becomes 4x plus 4 minus 3x equals 6. I still need to combine like terms here. So I have 4x minus 3x, which is just an x, plus 4 equals 6. I have to undo this, so I subtract 4 and get x equals 2. Okay, so again, you would stick this back up into the equation, substitute it, and then try to figure out whether or not it is the correct solution. You could probably use this one. As long as you get 6 on this side and 6 on this side, you'd be good. But again, if you did this part wrong, this would be wrong. So the best thing to do is to use the above. Okay? Okay, the next problem is a formula. This is the formula for surface area of a rectangular box. Sometimes we have to take formulas or equations and solve for a particular variable. In this case, we're going to be solving for h. So notice that h is right here and h is right here. So there's 2 h's in different locations that are separate from each other because, again, this one is being attached to a 2L. This one is being attached to a 2W. So we need to be able to somehow put them together but also remove the extra pieces. So I'm going to do this 2 different ways. We're going to solve for h in this one, and then we're going to solve for L using a different way. Either one is correct. The answers will look a little bit different, but it's still good. Okay. So notice again, there's an h here, there's an h here. This has no h at all. So I can get rid of this because it doesn't pertain to the variables here. So I can subtract this 2LW to the other side. And some of you guys may be freaking out. You're like, well, how can I do that? Because they're not alike. Well, if they're not alike, then you're not going to have to be able to subtract anything. So you're just going to rewrite it. S minus 2LW equals 2LH plus 2WH. So I noticed that on some of your pretests that a lot of you guys didn't like to rewrite after you've performed a process. I really think that's going to hinder you because you need to make sure that you write everything out step by step by step because that's a way of organizing your work. So please get into the habit of doing that because if not, you're going to end up dropping something, and once you drop something, the entire problem is wrong. Okay? So, like I was saying here, I need to separate, the H from these 2 L's and the 2 W's. So there is a h in common to both of these. It is a common factor. So if it's a common factor, we can factor out an h. So I'm going to do that. I'm going to factor out an h. When we factor out an h, we're actually dividing each of these by h. So remember, distribution was multiplication. When I take it out, I'm using division. So when I factor out an h, I'm going to have 2l left over here, plus, because a positive divided by a positive is a positive. If I factor out an h from the 2wh, I'm going to be left with 2w. Okay? I still have s minus 2l w on my left-hand side. Okay, so the only thing attaching this h to this set right here is multiplication. So I need to move this entire thing over here. So what's being done here? Multiplication. The opposite is division. So I'm going to divide the right-hand side by 2l plus 2h. But what do I do to one? I have to do the other. So I'm going to divide this side by 2l plus 2w. On the right-hand side, those are going to cancel out. So I have h by itself, which is what I want. And then this is your final answer. Again, it looks weird because we're not used to having an answer with that many variables in it. But it is correct. Okay? And then next we're going to do it solving for L a different way. Okay, same problem as before, but we're going to solve for L. Notice that L is here and here. I'm going to do this a little bit differently. Notice that each of these have a 2. So each of these have a common factor of 2, which means that I can factor out a 2 from each of these. So I'm going to take out a 2. So I have LW plus LH plus WH. And I still have my S on the left-hand side. I need to get rid of this 2 because this 2 has nothing to do with, or we don't really need it because we're again solving for L. So I need to get this on the other side. And the opposite of multiplication that's going on right here is division. Those 2's will cancel. So I get S over 2 equals LW plus LH plus WH. This one has no L at all, so I can get rid of this and bring it to the other side. So I get S over 2. I'm going to subtract WH, so I'm going to subtract WH. Again, I can't do anything because this is an S over 2, and this one does not have a denominator of 2, so I'm just going to rewrite it like this. Equals LW plus LH. I need to get the L out of these, so they each have an L. They have a common factor of L, so I'm going to factor out an L. So I get W plus H equals the S over 2 minus WH. To get L by itself, I need to get rid of the W plus H. These are being held together by multiplication. So the opposite is division. So we get those cancel on the right hand side, so our L is by itself. And again, it looks different from the one before because we did it a little bit differently, but it is still the same answer. Okay, and that's as far as you would go. Do not start canceling. This is as far as it'll go. Next, we're going to go over inequalities. We talked about the difference of the inequalities here. So this is less than, greater than, less than or equal to, and greater than or equal to. So if I had a question like this and I asked you to place an inequality symbol through the center, you would use a greater than symbol because a negative 3 is bigger than negative 30 because, again, negative 30 you're owing more, or if we're thinking temperature, this is a lower temperature than this. Okay? Review from 080, solving for a variable using inequalities. Very, very important. rule here. The rules are still the same. You still solve the equation or the inequality like you would do a regular equation, but you must flip the inequality symbol when you multiply or divide by a negative number. So remember on the very first example I went over, I told you that you wanted to try to keep your variable positive. If you do not keep your variable positive, you give yourself a negative variable, which means that you have to multiply or divide by a negative number, which forces you to flip the inequality symbol, which then gives you an extra step. Now, if you forget to do this extra step, not only is your answer wrong, but when we graph these on a number line, your graph is going to be wrong because you're going to be shading or pointing your symbols in the wrong direction. So, for example, if you had this, a negative 3x is less than 6. If I'm solving for x, I have to divide both sides by a negative 3. The negative 3's are going to cancel, and I get x is greater than, because again, because I divided by a negative 3, I have to flip this symbol from a less than to a greater than, and I get negative 2. Okay? Now back in OAO, we talked about how when we graph these, there's a certain notation that you use. If you have a less than or greater than symbol, you have to use an open circle, and then you shade on a certain part of the line. On this, you have to have a closed circle because it's equal to, again, you want to hold on to that point, so that's why we use a closed circle. Now, in this class, we're going to change it up a bit. Instead of using an open circle, you use parentheses. Okay? The parentheses, you only use one because notice how this parenthesis is pointing to the right direction because, again, the points are on the right-hand side. And then on this one, the points are going this way. So, if I am doing greater than, which is this one, I would use this parenthesis. If I was doing less than, I would use this parenthesis. Okay, so for example, if I had x is less than a negative 2, to graph that, I would go to negative 2, and I would want less than, so I would use a parenthesis, and I want to go this way. There is no more shading. The parenthesis is doing its job of telling you that I don't want negative 2, but I want everything going this way of negative 2, less than. Okay? Now, if I have these symbols, the less than or equal to or the greater than or equal to, we used to use a closed circle. We don't do that anymore. We use brackets. Okay, so think of the little brackets as being like fingers that are holding on to that number. So the same thing applies. If I'm doing greater than, I'm going to use that bracket, and if I'm doing less than, I'm going to use that bracket. So let's say, for example, I have x is greater than or equal to 4. I'm going to graph that on a number line. Here's 0, that's 4. I want greater than, so that means I want this side, so I'm going to use a bracket that opens to the right. So notice how the bracket is also doing the job of the closed circle because it's telling you want to hold on to that point because you've got those little fingers here, but it's also pointing into the direction of the greater than, which is to the right, which are where all the positives are at. Okay? Now, if you're not sure whether or not you graphed this correctly, or you have your parenthesis or your bracket going in the right direction, you can always pick a point within where the shaded area should be. So like right here, I could put a negative 3. Is negative 3 less than negative 2? Yes. So therefore, I know that's correct. Over here, I could pick 5. Is 5 greater than or equal to 4? It's not equal to 4, but it is greater than, so it does work. So, for example, we had that problem before that said a negative 3x is less than 6. And when we worked it out, we got x was greater than a negative 2. Okay? If I go to graph that, oops, wrong side. I want greater than a negative 2. Again, I don't have that little bar underneath, so I'm going to use a parenthesis. So I'm going to open this way. Okay, so that's what our graph would look like. Now I'm going to pick a point over here in the area that would be shaded, or in the area that is collected by this parenthesis, and I'm going to stick it back into my equation and check my work. I gotta make sure that it's pointing in the right direction and that all of these are solutions, right? So all of these points are solutions for this inequality, and all of these points are solutions for this inequality. Okay, so the easiest point is always 0. If you can pick 0, pick 0. If you can't, just pick the next one next to it. So I'm going to stick 0 up here. So I get a negative 3 times 0 is less than 6. Negative 3 times 0 is 0. And we ask ourselves, is 0 less than 6? Absolutely. So I know that I worked this out right, but I also graphed it correctly. Okay? Okay, one thing that we need to talk about, again, looking at the inequalities, is called a solution set. We want to know what all numbers are included in that solution. So if we look here at this one, x is less than negative 2, we see that it goes from a negative 2 all the way out. Well, what is out here? What exactly is out here? This is called negative infinity. You guys have probably seen that infinity symbol. It's a sideways 8. Okay, so what we need to do is we need to put this in a set. And a set is a set of parentheses that kind of show the range of the solutions. Okay, so we know that it's going to go from a negative infinity out to a negative 2. Okay, it's going to go all the way out to negative infinity, but it's going to stop at a negative 2. And you always want to start from the left-hand side of the number line all the way to the right-hand side of the number line. So again, notice I have a negative infinity and a negative 2. They're separated by parentheses. Now, either you're going to use parentheses or brackets, or a combination of the two. Now, because infinity is never ending and it will never stop, we have to use parentheses on this side. Have to. Okay, you should never have a bracket on next to an infinity symbol. Here, because this is already using a parenthesis, we would use a parenthesis because we don't want to use negative 2, we're just up to negative 2. Okay, over on this side here, again we start at the left hand side and we go over. Here, this is a positive infinity, or just infinity. Okay, so the solution set starts at 4 and goes out to infinity. But here at the 4, it was a bracket, so that means that you have to use a bracket also. And again, infinity, you always use a parenthesis. So in this case, we used a combination of bracket and parenthesis. So they will not always be parenthesis and parenthesis. And that is called the solution set. Okay, this is an inequality that we're going to work out. We need to solve for x just like we were doing before. You treat this exactly the same way as you would do a regular equation, is that we need to make sure that we follow the rules of keeping our x positive. If we cannot keep our x positive, then we have to remember the rule that we need to keep it or change it to a positive by dividing by a negative. And again, if we divide by a negative number, we have to do an extra step and flip the sign. So I need to simplify this by distributing here and distributing here. So I get 3x minus 3 is less than or equal to 5x plus 10 minus 5. Okay, all I did is I multiplied through. You would not have to flip the symbol here. Okay, the left hand side is simplified. I cannot combine these, but I can combine the 10 minus 5. So I'm going to get 3x minus 3 is less than or equal to 5x plus 5. Okay, now again you have a choice here. Either you're going to move the 3x or you're going to move the 5x. You want to try to keep this positive, so you don't want to move the bigger number, because the bigger number will change to a negative when we bring it over here, which will give us a negative answer. You want to move the 3x, so I'm going to subtract 3x on both sides. They cancel. Do not forget that that is a negative 3. Bringing down the sign with the 3 is less than or equal to 2x plus 5. Okay? So I'm going to work this out the same way I did before. This is happening first, and that is happening second. Again, multiplication is happening to it first. It's being added by 5 second. I start here. I subtract 5 on both sides. Do I flip that symbol? No. Remember, I subtracted. I did not multiply or divide, so I'm good to go. Here, I'm going to divide both sides by 2, so I get x is greater than or equal to negative 4. And some people may be going, well, no, that's not how you read it. You'd be saying negative 4 is less than or equal to x. But the thing is we don't care about negative 4 right now. I want to know, how is x related to the negative 4? So, when you read these, you always read from the variable to the other side. So this is x is greater than. Again, the greater than symbol is opening up to the x. So I can rewrite this as x is greater than or equal to negative 4. Okay? Even though these are in different orders, they represent the same thing. Now, some of you guys may not like that the variable is on the right-hand side. And when it comes to moving our x's, you may want to move this 5x to the other side. That's fine. But you have to remember, if you move this 5x to the other side, you're going to get 3x minus 5x, which is going to give you a negative 2x. Which means at the very end, instead of dividing by a positive 2, you're going to have to divide by a negative 2, which is going to force you to flip that inequality symbol in one of the last steps. And that is a step that a lot of people forget. I would rather you not do it this way. I know that you like to have that x on the left-hand side, but I'd rather you not do it because, again, you're going to forget to flip that inequality symbol, and then your answer is going to be incorrect. Okay, we need to graph this, so we would graph it on a number line. 0, negative 4. I would use a bracket because, again, it's got the less than or the greater than or equal to symbol underneath. So I would want to open it up this way. If I were asked for the number set, I would go from negative 4 to positive infinity. I would have a bracket here and a parenthesis at the infinity symbol. The next example we're going to be going over, the next couple examples, are applications. Applications mean, I know you don't like them, word problems. But again, this class is full of them, and it's important that we go over them now so that when we hit some of the more complex or the more involved ones, that we understand how to approach them. Got a couple of steps here. The first step is to read the problem. A lot of us have no problem doing that. It's the second step that we have problems with. Second step says to reread in chunks while writing down information. A lot of people assume, again, there's that word assume, we know what that means, that they can read it once and they know exactly what they're doing. It's really important that you go back and reread it so that you are that you understand what it's being asked of you to do. Step number 3, put together or use a known equation. If we're talking about perimeter, you should be using P equals 2L plus 2W. If we're using area of a rectangle, you should be doing A equals either base times height or length times width, things like that. 4, you need to substitute your known data. Okay, if you know what the length is, stick it in. If you know what the width is, stick it in. Step number 5 is you need to work it out, solve. And step number 6, check work and make sure that you check to see if you answered the question. That part right there is very important because the thing is, sometimes a word problem can be 2 steps or multiple steps, and you think that after working the first part out, you're done. Again, never assume that you're done until you know you've answered the question that they're asking of you. Okay, for page number 9, match example number 8, you should have written down something like this. We have an 8.5% sales tax. It told us that there was $190 for the title and insurance fee, and that for the total with the tax, the car, the extra fees that were there, that the total was $28,400. And the question was, is how much was the car? We don't know what the car is. So again, if we don't know what the car is, this is our variable. You can use any letter that you want to, but again, X is the one that we most commonly use. Okay? So we need to know what the total fee is. We need to know how to set this up. So we know that it's going to charge us for what? So with all this, we need to come up with an equation. So we know that we have to pay for the car. We have to pay for tax on the car. And then plus we have other fees that we have to pay for. And that is going to give us our total amount. Okay? This is what I mean by is just write an equation. You know you have to pay for the car, the tax, and the fees. Okay? So we need to put in what we know about this whole equation. We don't know what the car is. So that's our X. How do we figure out tax? Well, tax is a percent of the car. Why am I using parentheses? Because, again, of means to multiply. So I know that the percent is 8.5%. I can't use 8.5 looking like that, so I have to move the decimal 2 times to the left. So I get 0.085. So I'm going to move this down a little bit. 0.85x. Because again, I don't know what the car is. Okay, and the fees are $190. The total amount is $28,400. So, what I've done again is I've written down all of our information. I came up with a basic equation. I stuck our information into that equation, and now I need to simplify and solve. Okay? So I combine these because, again, they're like terms. There's an X here and an X here. And you're like, well, I don't know how to combine those because this has a number up front, this one doesn't. Remember, everything has a 1 out front. This is a decimal, so therefore this needs to be written as a decimal. So this is 1.0. If I take 1.0x and add it to 0.085x, I'm going to get 1.085x plus 190 equals 28,400. Okay? Then I'm going to subtract the 190 from the 2840. Okay? So again, I'm just going through doing my order of operations backwards. So I get 28,210 equals 1.085x. In order to solve for x, I have to divide both sides by this decimal. And I get x is 26,000. Okay? Dollars. Make sure that you label your answer. This is a money question, so therefore our answer has to be written with a dollar symbol. We go back and we reread our question, and it asks for how much was the car. So, that's it. Okay? One thing I did not mention, I forgot, it says that the fee was non-taxable, so that's why there's no tax on the fees. That's why we didn't multiply that by the percent. Okay, so what you would do, and kind of look at it too, is 26,000 a reasonable answer? Yeah, it's a reasonable answer because again, the total was 28,000. So if I had an answer of like 30,000, that would be completely off. If it were like 20,000, I'd be questioning that. Because again, we're only paying close to $200 for fees. It's the taxes again that's going to kill you. Okay? So that's that question. Since this is a business math class, a lot of the things that we're going to be talking about have to do with cost, revenue, and profit. So business type talk. C is going to be cost, R is revenue, and P is profit. In order for us to get a profit or to find out what the profit is, we have to take the revenue, so the income, and subtract how much it's going to make or how much it's going to cost us to make certain things. Okay? Based on that, that will tell us whether or not we have a loss or we have a profit. So, if I sell less than what it costs me to make something, then I'm going to have a loss. I'm not going to have any profit or any gain. If I'm going to have a profit, that means I have to sell more or I have to make more money than what it cost me to supply or to make a certain item. Okay? That is going to be needed for our next problem. Okay, on page 10, we're doing the matched example number 9. You should have read and then written down important information. It talks about having a fixed cost of $36,000, a variable cost of $10.40 per DVD, and that they sold for $15.20 each. Okay, so we need to find out, we want them to break even. So we need to find, that means that there's going to be no profit. So what does that mean? If we have no profit, then that means that we want the revenue to equal the cost. Okay, no company would ever really want to do this, but they need to know at least how much they need to sell in order to break even. Okay, so I need to find out what my revenue is and what my cost is in order to work this out. And we're going to start with our C, our cost function. Excuse me. So we have two things that say cost. We have a fixed cost and we have a variable cost. Okay, so what a lot of companies do is that there is like a mandatory fee to even start production. In order to pay for the electricity and things like that, there is a fixed cost you have to pay up front. Then they're going to pay you, or they're going to charge you per however many items that you're going to make. So we have a fixed cost and a variable cost. So again, we have like a mandatory fee, and then we have plus, we have a what they call like a variable fee. Okay, our mandatory fee is the $36,000. The variable fee is the $10.40. But the thing is it said per DVD. We don't know how many DVDs. We want to know how many DVDs are going to have us break even. That's our variable right there. Okay, notice variable, and look, we're using a variable. Okay, so we want to know how many DVDs. This is our cost function. So depending on if I want to make 1,000 DVDs, then this is going to be how much they're going to charge us per DVD, and then for actually making the DVDs. Okay, so this is our cost function. Our revenue function, it says that they sold for $15.20 each. Okay, so our revenue is $15.20 per DVD. Per means times here. Okay, and you're probably wondering why I left off the zeros. Those zeros are going to get in your way. They are not needed. This still represents $10.40. This still represents $15.02, or 20 cents, excuse me. So you don't need those extra zeros. Okay? Now, we have this equation and we have this equation, but what we're really looking at is this equation. We want the revenue to equal the cost. So I have to set this equation and this equation equal to each other. So the revenue is 15.2x equals 36,000 plus 10.4x. Okay? So I need to get x by itself. I'm going to do so by subtracting the 10.4x on both sides. I'm going to get 4.8x equals 36,000 In order to get x by itself, I'm going to divide both sides by 4.8. And x is going to equal 7,500. Okay, 7,500 what? This is where you need to label your answer. We're talking about DVDs. Okay? If you need to, again, you should check your work. Always on a test, especially in a test. If you've got extra time to check your work, please check your work. So you're going to stick 7,500 in here, multiply it by 15.2. It'll give you a number. Then you're going to take the 7,500, multiply it by 10.4, and add $36,000 to it, and you should get the answer, the same answer on both sides, so that you make sure that that is the correct solution. Okay? Okay, next we're going to do page 10, match example number 10. It tells us that the net annual salary, we want to find that for 1975. It says that in 2005 we had $100,000. So it says what net annual salary in 1975 would have had the same purchasing power over a net annual salary of $100,000 in 2005. Compute your answer to the nearest dollar. So in the book, you have to use this table that's on page 10. I know it's a little bit blurry, but there's no way of focusing that. So again, you need to use that. In this question, we are talking about two dates. We're talking about 1975 and 2005. Okay? So it says, what is the salary in 1975? We don't know what the salary is for that, but we do know what the salary was in 2005, and that was $100,000. Okay? So it talks about the CPI, which was in your book. Again, it was the cost. I forgot what it was already, but it's in there. If you use that table, there is a CPI number for each one of these dates. Okay? For 1975, it was 53.8. And for 2005, it was 195.3. Okay? So, again, the reason why I'm setting it up like this is because we had two pieces of information. We had information on salaries and we had information on CPIs. These work together. Okay? This CPI is going to tell us what the salary is for this, and this CPI goes with the salary for this. So they are related to each other. When they are related to each other, they are equivalent. Okay, this is called ratios and proportions. What you're going to do is cross multiply. You only cross multiply when you have an equal sign here. So we cross multiply here. We multiply those two together. So we get 5,380,000 equals 195.3x. Okay, and the way that I got that was by using the other diagonal. And then to solve, we would divide both sides by 195.3, so that we would get x by itself, and then solve for x by dividing. Okay. Really, you would have gotten $27,547.36, but again, it said to round to the nearest dollar. Since this is not quite half a dollar, we would keep it at $547. Okay? So make sure on your homework that if you have any questions, either hit that button that says show me an example, or use the button that says ask my instructor, and I will let you know. Good luck.